In this video, I'll be doing all of the questions from the Chapter 3 test in the book. I recommend when watching this that you fast forward to questions that you need the most help with, skip questions that you don't need help with. Also, keep in mind watching the video is not enough, so paying attention to what I'm doing, understanding what I'm doing is not enough. You need to practice on your own and check your answers, okay? Don't forget that, that's a huge part of it. Okay, I'm going to start out with number 1. The instructions for number 1 say test each number for divisibility by 2, 3, 5, 9, and 10. Okay, well I know this is divisible by 2 because it's even. It's divisible by not 3 because when I add the digits, 7 is not divisible by 3. It is divisible by 5 because it ends in a 0. It is not divisible by 9 because it's not divisible by 3 twice. And it is divisible by 10. Number 2, the number 405, it is not divisible by 2. Since 4 plus 5 is 9, it is divisible by 3. It is divisible by 5. It is divisible by 9 because it's divisible by 3 twice. Also, a rule for 9 is if you add the digits and it's divisible by 9. But if you don't know that, we can divide by 3 and get 1. And get 10, so that's 3 again. And then 15, so we get 5. And then 135 is divisible by 3 because these add up to 9. And it is not divisible by 10. Problem number 3. So for number 3, it's 628. It is divisible by 2 because it's even. It is not divisible by 8 because 8 plus 2 is 10, plus 6 is 16, and then 1 plus 6 is 7, so it's not divisible by 3. It is not divisible by 5, or 9, or 10, so just 2 for number 3. Let's go to number 4. 837 is not divisible by 2. It is divisible by 3. Not 5, 9, I'm not sure, let's see, 7, 10, 18, it is divisible by 9 because it's divisible by 3 twice. I don't actually know that, but I know it's divisible by 9 because they add up to 9, but we can do the 3 twice technique here. 23, 7, 21, 27, so 279 is divisible by 3 because you can add them up, 16, 18. So just 3 and 9 for number 4. Moving on to number 5. Say whether each number is prime or composite. 19 is prime because it's only divisible by 1 and itself. 39, I know that this is divisible by 3 because these digits add up to 12 and 12 is divisible by 3. So 13 times 3 is 39. So that is composite. This is prime. Number 7, 51 is also divisible by 3, so that's composite. Number 8, 67, 7, so it's not divisible by 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 or 11. So now I'm just basically checking prime numbers. It's not divisible by 11 or 13. Let's see. 39, 52. Nope, not 13. 17. Yeah, I don't think 17. 34, no. 19, no. 23. No. So I'm going to say this is prime. I haven't checked every number, but I went pretty high. I went up to 23, so I'm pretty confident. Starting on number 9, prime factorization of 72. You can start these any way you want, but the final answer should always be the same. Okay. Keep in mind, I put these dots here because these are multiplication. Some people tend to forget that and they put addition. So the final answer, let's do these in order from least to greatest. You can write it like this, or you can write it like that. That was number 9. Prime factorization number 10 starts with 80, so we have 8 times 10. We have 4 times 2. We have 2 times 5. Keep in mind, every level of your tree, or every row in your tree, should multiply together to get 80, and I highly recommend you double check every once in a while. So 8 times 10 is 80, 4 times 5 is 20, times 2 is 40, times 2 is 80. So just double check that you haven't made some calculation mistakes. And I do it when I get to the end as well. 10, 20, 40, 80. So we can write it, it's already in order, but we can also write it like this if we want. For number 11, the number is 120. Let's start like this. Let's see, we get a 4, we get a 2, and a 5. That 4 becomes a 2 and a 2. Alright, now I'm going to double check. So I got, we'll do 15, so the 5 and the 3, 30, 60, 120. So I can write it like this if I want. Alright, let's try number 12. Number 12 says find the GCF of each set. Alright, so we're looking for 24 and 36 GCF. So I'm going to make factor trees again so I know this. Whoops. Let's go back up there. So this is going to be 8 times 3, 4 and 2. So this is going to be 2, 2, 2, and 3. And this one, I'm going to start off with 2 6s. Then these are each 2 and 3. So I'm going to have 2, 2, 3, and 3. So in common, they have 2 2s and a 3. So the greatest common factor is 2 times 2 times 3, which is 12. Number 13. We have 3 numbers, 20, 25, and 30. So we have 10 times 2, 2 times 5 times 2. Here, what is that, 25? Yeah, 25. Alright, that's 5 times 5. 30 is 3 times 10, 2 times 5. So if we put these in order from least to greatest, they do not each have a 2, so we're not going to use that or that. They do each have a 5, and since we've run out of numbers for this one, 5 must be the answer. GCF equals 5. Alright, number 14, 7 and 19. Well, these are both prime numbers. I know that right off the bat. So this is the only case I'll actually write a 1. So the greatest common factor is going to be 1 here. It's pretty easy. When they're prime numbers, the GCF is 1. No problem. Less work for me and you. Number 15. Looks like a word problem. For a writing workshop, 15 coaches and 35 students will be split into groups, each with the same number of coaches and the same number of students. So each group has to have the same number of coaches and students. At most, how many groups can there be? Okay, well, 15 and 35 are going to have to be split up evenly, right? So at most, how many groups can there be? Well, this is 3 times 5, and this is 3, no, whoops, not 3, 5 times 7. So if we split them up into 5 groups, these are what, teachers, and these are students, we could get 5 groups that each have 3 teachers and 7 students, right? That would be, so 5 groups with, and then 3 teachers, 7 students, right? Because that would be 15 teachers and 35 students, which is what we had. Good. Number 16. 8 friends want to go horseback riding. The stable charges $23 per person. Find the total cost for the group to go horseback riding. Well, 8 friends at $23 per person is just 23 times 8. So $184. All right, let's go on to number 17. Just flying through this. All right, each expression using an exponent. Name the base and the exponent. Okay, so this starts out as 10 times 10 times 10 times 10. So the base is 10. The exponent's going to be 4, 10 to the 4th. For number 18, we have 6 p's. P times P times P times P times P times P. So the base is P, exponent 6 for 6 of them. Number 19, simplify each expression. 4 to the 3rd minus 1. I have to do the exponent first. 4 to the 3rd is 64. Minus 1 is 63. All right. Oops, got to set my clock here. All right, going on to number 20. Looks like I'm not going to have enough time to finish this, because I want to make the video less than 15 minutes, so I'll just make a part 2, no big deal. So for number 20, we have 2 times 3 squared. Exponents come before multiplication, so it's going to be 2 times 9, and then 2 times 9 is 18. 21. 150 divided by 5 squared. Again, exponents come before division, so it's going to be 150 divided by 25, which is 6. All right, let's try 22. 36 minus 8 minus 6 to the 4th. That's an 8. Parentheses come before exponents, so we're going to do 36 minus 2 to the 4th. And exponents come before subtraction, so we're going to do 36 minus 2, 4, 8, 16. And then 36 minus 16 is 20. Looks like we got some more word problems. So number 23. Today, 2 neighbors water their lawns. 1 neighbor waters her lawn every 4 days. So day 4, day 8, day 12, and so on. Right. The other neighbor waters his lawn every 3 days. So day 3, day 6, day 9, day 12, and so on. In how many days will they water their lawns on the same day again? So we're pretending we're on day 1, right? 1, 4, 5, 6, 7, 3. Oh no, okay. So let's say we're on day 4 randomly. No, that's not going to work. So we're on day 12. This is the first day that they're actually doing it together. So how many more days till that happens again? Well, this is going to be 12, 16, 20, 40, 12, 16, 20, 24. This is going to be 12, 15, 18, 21, 24. So from 12 to 24, so it's going to be 12 days apart, which happens to be the least common multiple of 3 and 4. If we make our little chart, 2, 2, and 3, right? 12 days. Oops. 12 days. There we go. Okay, I'm going to stop this video and go to part 2. Thanks.